Ananth. He graduated from National Institute of Technology, Surathkal, Karnataka, and has done his post-graduation from Rensselaer Polytechnic Institute, New York. He has 20 years plus experience in EDA industry. He is presently working in Cadence as a group director and manages the India Field Organization for Digital Products. Can we have a big round of applause for Dr. Ananth?
To give out, okay? I'll ask questions now. So nobody asks questions, so I ask questions. Ravi is not allowed to answer. First question, since we have been talking about ML the whole day, right? ML joke, okay? Kannadalli helala, English alli helala. Oh, Kannada, okay. Illa Kannada premigalu jaasti. So, oba ML enthusiast bar hogtane. So the bartender will come and ask, "Yav drink beku?" So what will he answer? Anybody gets it close, will get a chocolate. Dairy milk. Repeat the question. An ML enthusiast goes to a bar. The bartender asks, "What drink would you like to have?" What will the ML enthusiast answer?
90 ml. 90
Did I hear lemon tea? No, that's not the answer.
90 ml.
No green tea, no lemon tea, no masala tea. Yeah.
90 ml ಅಂತ ಇದೆ.
90 ml ಅಲ್ಲ. Okay. Nobody. Oh, yes, ಅಲ್ಲ. Okay. The thing is, you should think like a ML. How many of you have done ML programming, Python programming? People have done it. Then you should know the answer. Okay, let's look like Ravi. You can answer. A 90 ml is not the answer. Okay. Standard ML. What does ML need as an input? What is everybody else drinking? Because he needs data. So that's the most important. ML basically decides based on data. Nobody got it right. Sorry. Okay.
Wrong question.
Very deep question, right? Yeah. I'll have one more question. This is not a bar question, so don't get excited. So this is a. Who can tell me the full form of EDA?
Electronic device.
Okay. All of them together. Okay. So now the next question is, who can explain what happens in EDA? I know the full form, I think, as it's told. Who can tell what really happens in EDA? Where does it fit in the VLSI flow? Who can talk about that?
Sir, previously SSI and MSI in that we can trace up only 10 number of transistors or 100 number of transistors. With the EDA tool, we can implement a more number of transistors in a single chip and we can do the automation.
Oh, very nice. Okay, nice answer. Thank you. I like the answer. And obviously the same engineer can do a lot more chips. Still my slides are not coming. I can ask more questions with it. Another ML question I can ask now. Oh good, everybody knows Cadence. I think you primarily know Virtuoso, right? Is that right? Okay, I don't handle Virtuoso. Okay. Personally, in my role as provider, I am responsible for the digital set of products, which is used for digital design primarily. And we have a bunch of products, and if you were to go through the Proxelera training, you will understand the VLSI design flow, and as a part of that flow, you will have multiple steps, and there are digital products at each step. And I handle the Cadence portfolio for the digital set of products there. Okay. How the EDA space is changing. There are a lot of slides here. Probably not going to too much of technicalities, but at a higher level, try to see how EDA is getting transformed from what it was a few years back to what is coming in the future. So that's going to be my topic for ML, data science and ML, which is making huge waves. The amount of computing needed to overall save data, to analyze data, I think that's making a big wave. Second is hyperscale computing. As you can see, a lot of the hyperscalers, typical hyperscalers are referred to some of these companies like Google, Microsoft, who actually started designing their own chips. And the amount of computing needs which they have, whether it is in the cloud or at the edge, so it needs a lot of computing which has to happen. Autonomous vehicle, obviously now I do hear a lot of ADAS. I think a lot of people have started hearing of ADAS level 2 coming in the latest Hyundai Tucson, right? So those are all part of the autonomous vehicles, and 5G and 6G is just released. So that's one of the other electronic drivers. At the industry level, there is a lot of automation in terms of sensors. One example I want to give on sensors, maybe it's related to vehicles though. I was in a Tesla in the US recently. And the first few earlier version of Tesla, what happened is when there is a bump, it used to hit as it happens in any of the sedans in Bangalore also, right? They solved the problem in 1 month. How? By giving a software patch. So basically, as soon as the front tire hits a bump, they harden the shock. Yeah, and then it hardens and doesn't bump up and down and avoid hitting the bump. So they have been doing this sensor stuff, and that is the IoT part. Sensors can be anywhere, industrial as well as in cars. And life sciences, especially COVID, has actually revived this industry. A lot of computing needed to come up with newer vaccines, especially which are we don't know what is coming next though, but hopefully we are there. Next slide. So this is how our electronics industry is growing today. At a 9% annual growth rate, we'll hit around $1 trillion by 2029. So we are part of this industry, and obviously there is a huge scope for you guys to come into the industry as well. So there is a huge growth opportunity. Obviously India is doing much faster than this. This is the worldwide growth rate. And if you were to look at overall systems, typically there is silicon, which is the center. There is a lot of silicon design chips which are getting designed, and around it is the systems where the silicon gets placed, maybe a mobile, maybe the car, right? These are the systems around it. And the last layer is the data, where there are apps on your mobile which generate data. So all these need to be an essential component of a system. So in order to design a chip today, it is no more an independent problem. You need to understand the overall system. You're designing a chip, where does it go fit in, and what is the overall environmental factor. So you need to have all three aspects in mind when you're designing chips. That is the difference today. Earlier days, we were given a spec, you go and implement a spec. Right? Now, you need to understand the complete system before you make the right choices, the right decisions in chip design. Okay, and obviously there's a lot of buzz around AI, ML. I just want to talk about a few of the AI components which are in semiconductor design today. One is, as you can see, the semiconductor industry is going through a big change. I mean, all these drivers are coming into picture, and designers are under extreme pressure to cater to the latest needs. I mean, if you were to look at 5 years back to now, design companies are churning out a lot more chips, maybe double the chips they were doing before, and also bigger size chips as well. So obviously with all these put together, there is a lot of pressure to do things faster and more efficiently. And that's where AI and ML is basically playing a role. And I think that I can substantiate that in the next slide. These are the various nodes, lot of system level work happening. Obviously, there's a lot of effort involved. The effort involved is high effort. So how do you learn? I think this is basically a ML. I think people who study ML would know that you learn from the previous, create a model so that you don't repeat the same mistakes. That's basically the ML model, and which is getting used very heavily in semiconductor design, not just in design aspect as well as in EDA. So both actually are using it heavily. So this is just an example of to show how AI is helping. So if you remember, many years back, there used to be manual design where you used to put polygons, right, to design chips. And from there, we transitioned over to transistors. There was a 10x productivity boost. Then we moved from transistor to cell-based design. We have standard cells, we use that. That's again a 10x productivity boost. Then we started reusing components. There is already a USB 2.0, you use component IP reuse, so there's a 10x productivity boost. Now, the next 10x productivity is basically coming with a lot of AI inbuilt in some of our EDA tools. I think that's the next generation we are looking at. And that's how AI is basically revolutionizing the overall semiconductor design today. So if you look at ML, typically EDA, I don't know how many of you understand EDA problem, but it's typically a mathematical problem. How do you solve it? And these are typically NP hard or NP complete. So it's very hard to solve them. There's no perfect solution. And if you want to arrive at a perfect solution, the runtime is so long that you just cannot get practically possible. So with all that, that is where ML is basically playing a role. So nowadays in the industry, how was this managed previously? People used to tend to do over-design. For example, if you're designing a 3 gigahertz processor, you tend to put in margins, you design for 3.5 and hope on silicon it will work for 3. Right? You tend to basically over-design. Now you need to reduce the margining, you need to reduce the over-design. And that's where ML plays a role, so that you can learn from what happened previously, or even in the EDA flow, if you can learn from next steps of the flow, you can make some decisions early on. So for example, right, say assume you have a design which has an adder in it. So you need to decide what type of adder needs to be used, whether it should be a look ahead, or a propagate ahead, or a carry save, right? How do you make that decision early on? Is it, the only way is you should know what, is it in the critical path? Is it going to affect your frequency of your overall chip? Unless you know that, you can't make a choice. Because if you were to make a choice on a faster architecture, then the power will be more, area will be more. If you were to make a choice on a slower architecture, then it could basically become the bottleneck for your entire chip. I think these decisions have to be made early on in architecture stage. Now that is only possible if you can understand what is going to happen later on in your EDA flow. So is this going to be the critical path? So these are the ML feedback loops which has to happen so that you can make the right decision early on. That is just one example to give, but this is what typically EDA tools are all about, and they are trying to make this automated to help the decision making faster. It's pretty much showing very similar stuff. I mentioned architecture as an example there, but there are a lot more other components, whether it is standard cells or floor plan, constraints. These can be a lot more factors in the design flow which actually impact. And that's where ML within EDA is actually helping speed up some of the effort or reduce some of these high effort components as a part of chip design. This is just a slide to show Cadence's solution today. On top of a data platform, we are actually building a lot of products which are based on ML. I am primarily involved in this product called as Cerebrus, which is actually a very key product for us in the upcoming years to basically help productivity. Okay, the next framework, which is changing the industry today, is 3D IC. If you go to the next slide. The challenge here is when you take a chip, whether you place it in a mobile, you will face a lot more different environmental conditions, whether it could be electromagnetic interference or thermal or cooling, or when you place in a car. So I think that's the reason your considering overall mechatronic, I think that's the word, where electronics plus mechanical, everything needs to be considered as a system when you're designing, and that's what is making it very complex today. And that's where the 3D IC is basically going towards. We go to the next slide. What happens in 3D IC is, say, assume you have a CPU and you have a memory. So do you want to place it on the same die next to each other, or you place it one above the other so that you can connect them through silicon vias? So I think these decisions are very important now, and it's very similar to Bangalore or Mumbai, for example, right? There is no space available, you go upwards. So it's as simple as that. So you try to stack. I think that's the direction which the industry is going towards now. With, I think, as Sankal put it, right, is this going to be successful? At least I feel yes. It looks like that's the only way out today. There's no way we can actually build dies which are monolithic in nature. It's no way we're going to. It's practically not possible. We'll have to stack them. And then a lot of industry trends in the same direction today. I think 3D IC has become far more important because, for example, there are 3 dies, one over the other. The top die, the environment is a lot more different than the middle die compared to the bottom die. So there are various factors which come into picture when you're considering each of these, and that is where does this overall fit in, right? Whether it fits in a car, whether it fits in a mobile, I think these becomes really important. This is Cadence's 3D IC platform. It's called Integrated. Basically, it has hooks to various parts of the tools to actually do a 3D IC design. I'll not go into details of this. But the last one is the cloud. What is happening is when chip design typically happens, you need a lot of compute, especially the peak compute is very high in a project. And catering to peak compute, and if you have to keep so many machines available, it's not practical. So that's the reason a lot of companies now, especially to handle some of their peak needs, are moving to the cloud. I don't know whether Proxilla is going that path, but a lot of companies moving to Amazon Web Service, AWS, or maybe a Google Cloud, and so a lot of cloud services available today. And even Cadence has its own cloud, where it's either can be a Cadence managed cloud, or it can be a customer managed cloud. We can just give machines and with the software. But a lot of focus on cloud today because of the need for compute. I think that's also changing the dimension of the EDA industry as we speak. Just a quick overview on what Cadence does and where does it work on in all this right now. Cadence is basically the leading provider for intelligent system design solutions. We call ourselves as computational software because we have a core engine which actually can be used for electronic design. Actually, we also can use the same to do computational fluid dynamics as well. So that means we can cater to physics, electronics, physics, as well as we can actually cater to a design of a car to handle some of the computational fluid dynamics. So just recently, Cadence announced a partnership with McLaren to basically design the car of McLaren, and actually we have all of us got caps and all from McLaren for that purpose. Basically Cadence is, this is the system design AI ML IP, right? So there is explosion in data, Moore's law is becoming harder, and complexity of design is growing. So all these put together is basically bringing the best out of EDA as we speak. The last slide, I think. This brings to my last slide. So where at the center there is core EDA, which basically helps in electronic design, and then you basically expand that to do systems, and finally you have data, AI, and algorithms to handle the overall data to basically see where it fits in. So that is the direction intelligent design strategy is taking us to, and that's the reason we are also computational software is our core competency, and that's the direction Cadence is taking. That's my last slide. I can take any questions. So I think the question from is that how much is the AI ML work happening in India? A lot. actually. Right now I mentioned this product called Cerebrus, which is basically sits on top of our PNR solution, and it helps design chips and achieve better performance and power. And majority of the R&D, I want to take a step back, right? Typically in Cadence, any EDA company for that matter, there are two primary roles. One is R&D, second actually we call it field or sales, whatever you call it as. So the R&D organization is the organization who is developing the software. And the second organization is the sales or the field organization who are trying to sell the software. Obviously, that sale doesn't mean just, it's not pure sales, it's technical sales where the sales organization need to understand customer requirements and help them get through certain chips. So now if I were to talk about the Cerebrus, a lot of R&D happening today in India. And in terms of the field organization as well, one of our core objectives for 2023 is to sell a lot of Cerebrus. So that means as an application engineering team, we need to understand how AI/ML works, what are the various use models. Since AI/ML itself is a new concept, the use models can be varied. So different customers can use it differently. So I think we are also trying to figure out, some customers are using it to get better power. Actually recently we saw a customer was able to achieve more than 10% better power using our AI/ML solution. Another place we saw customers using it for productivity. For example, they did a chip where they put 10 designers to do 10 blocks. They used this product, they put 2 designers to do 10 blocks. So they were able to use it for productivity gains. So there are different use models, which we are also exploring. We have the engine out there. We are also exploring different use models, use corner cases that are coming up. There are a lot of exploratory work. Actually, a lot of R&D also customers are doing using some of these products. I think that's the reason AI/ML is a lot more important, and it is with the tools coming in. So it's called AI/ML within the tool, AI/ML outside the tool. There are two concepts. So this is, we are talking about AI/ML within the tool. Now on top of this, customers are also building their own AI/ML platforms where they can actually learn and do things faster. I don't know whether I answered your question. Is there any other question?
Contribution of Cadence in VCI and AI integration. Cadence contribution towards the BCI, that is brain-computer interface, and AI applicability. I want to know what is this position of that particular
BCI and AI. BCI is that interface, right? I'm not fully familiar because I'm not a IT expert, so I will not be able to answer that properly.
Because you just have some sensors over your head, you collect some information from brain.
Oh yeah, that's the standard. We are talking about the third layer, that is the data layer. Yes. Typically, the way Cadence operates is, Cadence is a provider of tools. We provide tools to design your chips. Second layer is a system where customers like Intel, Qualcomm, big, small customers will use that and design their chips, and that goes into systems, whether it could be mobile or could be cars. And the next level is the data. I think you're talking about that layer. Yeah.
I have a question. Yeah. So, is it not the monopoly in the EDA to grant? That is
monopoly. Okay, this is a business question. Okay, I like business questions, but yeah, I don't think there is any monopoly as of now. Synopsys and Cadence, as well as Mentor, which is acquired by Siemens now. Okay, so I don't know, we call it monopoly. There are 3 very strong, plus ANSYS as well, right? 4 strong players today. So I wouldn't think there's any monopoly at the moment.
With respect to the
Even though if you were to look at it, if you were to look at core EDA, we call it core EDA where it is purely digital design. I think pretty much equal share, maybe 1 year, maybe Cadence is higher, 1 year Synopsys is higher. That's the way it is.
Over the decades, we have seen that transistors are continuously scaling down. Now I think it's a 3 nanometer right now. And I think Samsung is also working on gate-all-around technology. So with respect to the scaling of the transistors, So I think the EDA tool vendors, they are also facing challenges with respect to the process technology. So do you have any such experiences?
I can share some part. I don't know whether the TSMC NDA allows me to share everything. I don't know, but I'll share it high level. As you rightly said, right now, lot of customers, especially customers who are trying to do cutting edge design, 3.5 gigahertz processors, 4 gigahertz processors, obviously are on 3 nanometer. Now, 3 nanometer, what I think TSMC also has, and even Samsung also provides. And as you rightly said, 2 nanometer is also coming, gate around is there. Now, the challenges which come with every node is a bit different. So for example, 3 nanometer brings in its own unique challenges. How many of you, I don't know, are familiar with physical design? Typically physical design, a bunch of rows, the standards of the same height or maybe double height, triple height, 4 heights. You go and place them in the right blocks, right? That's the standard. But 3 nanometer is not like that. It has, we call it multi-height, which is not even, it's not 1x, 2x, 4x. It can be something else in between. So handling that becomes a challenge. So that's one of the biggest challenges which 3 nanometer, for example, from TSMC is bringing up today. And handling that is one of the biggest challenges, at least. I will not go into too much details because I think the NDA might not allow.